Hello, I'm Nathaniel, and today we will now do question 1 of step 2, 2020. So, as you can see with the long S, it's called an integral sign. It's a calculus question. So the tools needed are the integration by substitution. So how do you do an integration by substitution? First, you calculate dx over du, which turns out to be negative 1 over 1 minus u squared. Now, dx equals to negative 1 over 1 minus u squared du, because we can just multiply both sides by du. This is only one of a few cases where the differentiation behaves like normal fractions. Now, d just happily turned out to be, the fraction turns out to be 1 minus u squared over u 3/2, and then 1 over 1 minus u squared. Oh, and don't forget this is supposed to be a half. And then we can just delete these, because don't forget this has a negative sign in front of it, and then we add another negative sign and it becomes positive, which means that we can just simplify it to become u to the power negative half du, which, if you know your integration formulas, which is called the product rule, which is the power rule, and then you had this. Then you calculate using the simplification and the substitution, 2x over 2, 1 over x half plus c. Then we are now done with part 1. Now let us do part 2. Part 2 is gonna be quite challenging, for it requires a double substitution. Let's call our variables s and u. Now s equals to x minus 2. We are strategically changing our variables so that we are able to remove the terms. And then we can have 1 over s3 over 2 s minus 3 half dx. And then this is shockingly similar to the first question, but we have s minus 3 instead. Now, using the substitution, s equals to 3 over u minus 1, we will have u minus 1 squared over 9 u half minus 3 over u minus 1 squared. Now, we can just cancel these two out to get, well, negative 1/3 u to the power negative half du equals to negative 2/3 u of half plus c. Now, we can simplify this even further to get negative 2 over 3 s plus 1 over s half equals to negative 2 over 3 x plus 1 over x minus 2 half plus c. Now, this question I really had to think about it, but in the end I was just trying to do it, and with normal single substitution, turns out it doesn't work. But another method is to try using partial fractions, taking a square root of this, and then you can substitute say a half root for u, say, after we done the x substitution. Then it would be much easier to do it and think of it as partial fractions rather than very cumbersomely turning it into a power. Sometimes things like this cannot be done, but you can change it to a simple trigonometric or exponential expression. Other times you had to do it integration by parts. It's not avoidable sometimes, but we see a quote from my math teacher: with differentiation you can apply the rules, but with integration you can still apply the rules, but you have to do it 57 times. You may have to do it 57 times. Anyways, so for part 3, x equals to 1 plus u over u. Doing the integration gives us infinity to the monstrous integral. Let's just write 1 over x minus 1, x minus 2 half, 3x minus 2 half dx equals to, well, then if we substitute 1 plus infinity over infinity, we will have 0, and then when we have 1 plus 2 over 2, we will have 1. So there, we just substitute in our limits, and then if u is 1, x is 2, if u is 0, x is infinity. There, and then we get u squared over 1 minus u half. 3 plus u half, it's because 1 plus u, and then you take the negative sign of both. Negative 1 over u squared du, because that's, well, the derivative. And dx, just to make sure that our multiplication is correct, we just say dx equals to 1 over u, negative 1 over u squared, and the next bit is a constant, du. So that means our multiplication is correct. Let us delete this bit so that we can have space for our extra working. Now, well, we might be stuck here, but help is at hand, for we can just cancel the u squareds. A thing that might be routine to you students, just cancelling out terms. And it's quite, therapeutic to just cancel out some terms. But you might be thinking now, I'm just expanding the brackets and it might make the problem more difficult to solve. Well, how do we do this? We are now going to complete the square. Since this is a square root of 4 minus 1 plus u squared du. Now you realize this. Hey! It's a sine inverse! Well, you are not really expected to memorize these integrals, but you can just write down a handy formula sheet, but instead you may have to. I don't know, but you can just memorize these, okay? And then you will have sine inverse 1 plus u over 2, that's the standard formula, 1, 0, equals to sine inverse 1 minus sine inverse half, which is pi over 2 minus pi over 6, which gives us the legendary pi over 3. Now, how do we can actually construct integrals like this. My favorite is the one which amounts to 22 over 7 over minus pi. You can go look that up. It was actually an exam question where they are probably just engineering integrals to give elegant answers. Well, now the 22 over 7 over minus pi one might be more interesting to think about, because it's a similar type of question where you can just expand the brackets and probably do a substitution, and this integral is used as a proof in pi of 22 over 7 exceeding pi. Now that's a curious integral to think about. See you